So, like I have in the previous streams, I will be doing my normal random paint drawing segment. So I got my calculator here, and I will get my first number, which is 16, and that is a toilet. This is off to a great start. My second number is 24, which is starving. Actually, no, that's clothe, which is a verb. And my third number is 17, which is Pointy. So, this seems pretty straightforward. So we can have a, let me pull this so I'm looking at the screen. Um, so let's say we have a toilet to begin with, and alright, I've lost my bearings there. Let's say we have a normal toilet, and it will have a back and a bowl, and then we will have this weird shape in the back that allows the water to get flushed out in a vacuum. And then, so we have the top, and that is our toilet. We can have a handle, and I'm not sure why it's a circle, but we're going to assume it's some sort of prototype twist handle that is allowing for a selection of the maximum or minimum or anywhere in between amount of pressure for the flushing mechanism. It's an economically friendly toilet. So we have our little green leaf here to symbolize that it is friendly to the environment. So if we have a pointy toilet, then obviously the toilet I have drawn is incorrect. So we will show that this is actually a sharp toilet. It may be a modern twist on the current toilet design. I know that when you get to a higher state in society, you tend to have fancy toilets. So we will assume that this is some strange eagle-mouthed toilet that engulfs, and I'm glad that we didn't have to do starving, because that would have just had way too many defecation jokes. So this toilet has a moment here, moment M, that shows the rate of the angular velocity of this swing here, and this pointy toilet seat will possibly cause problems if it were at an angle other than 0 or 90, but we will assume that most people are up to the challenge of moving the toilet seat to one of the preferred positions. So we will eliminate that problem from our analysis. So then we need to consider how this toilet would be clothed or be clothing something. Perhaps it could be the clothing itself. So it could have a opening here and a symmetric opening on the other side for a perhaps a small child to sit in, so that this said child can go to the bathroom whenever they wish, but they can immediately flush with a twist or a torque in the engineering community this way to a preferred amount of pressure, so that the waste can be removed adequately, and the parents can go on with their daily lives, not having to worry about cleaning a child. That is not what I wanted. Obviously, I have been slacking on my closing in of my shapes here. So here we should be able to color that, and no, we cannot. I see where the problem is. So I will continue to babble until I succeed at what I'm trying to do, and I have failed you once again. I do see where the problem is this time, so I will move on to clearing off this problem, and I will this time scan the area for more problems, although I am not seeing any, so I will continue. Now, I do foresee some problems with this design. There would be some water leakage here with a flow rate of m dot. This would equate to some volume of water in gallons. So this could be L gallons. I'm not sure why I would use the variable L, but I could not think of anything specific to its necessity. So this would cause a problem unless we had some sort of plug to go here that would allow the leg to exit the toilet through the bottom, but at the same time not allow water to exit the toilet. There could also be some sort of design where there is a channel here that allows the water to flow between the legs but not around the legs. Now, there will always be some sort of mist coming out of the toilet, and this is where we will see a Q out, and that's the rate of heat out, and also a m dot where we are losing some water, but this with a channel system would be much more efficient in terms of not losing internal energy. So surprisingly, I think that we have a fairly well analyzed picture here, and I think that we should be able to move on with our lives knowing that a toilet seat or a toilet pants would be applicable to babies. Now, this would have to be either a fairly light toilet, or it would need some sort of strange pulley system that would allow it to walk on a stand that had wheels attached to the bottom so that the baby could move around and not be burdened by the weight of this toilet. If anyone knows anything about porcelain, the density allows it to be fairly heavy for how small of a piece of porcelain you get. Now, this does not equate to anything of metal, but it is fairly heavy as a whole, because you can imagine that it's just a rock. So babies don't do very well at carrying large quantities of rocks, and so if we wanted this to work, there would have to be some sort of weight displacement system. This could be similar to a baby walking device, because we know babies need help walking. I need help walking every once in a while, but that's on a side note and maybe a story for another day. So we can assume that it'd be something like one of these bouncy baby walking devices, and the baby would be able to move freely, and even better than if it were not wearing the suit as a whole. Now, there would also be problems of waste disposal, but this could be solved by a long chain of pipes that would lead to wherever you wish. And the added benefit of this whole system is that a baby would have a minimum possible range of walking, because those pipes would act as a leash. So it would be possibly even a more society success. I need words. a more society acceptable version of a child leash. So I think we have a finished picture here. It seems to be fairly well explained. So I will be signing off here.